The commutative property says that you can switch the order of the elements around the operation and it's the same thing. In other words, 6 triangle 7 needs to equal 7 triangle 6. And if it doesn't, then this doesn't obey the commutative property. So let's go to 6 on the row. So 6 on the leftmost column, we're considering this, this entire row of elements. Then triangle 7. So 7 on the columns. These columns going down. We're considering 6 going across the row, 7 in the column. So that value is going to equal 7. This, according to our table, is 7. And then if you want to do 7 triangle 6, that means you start on 7 on the row, 6 on the column. Oh, they're not the same thing. So this does not obey the commutative property. The associative property says that you could change the order of importance and it should be the same thing. So in other words, with parentheses, if you change the parentheses, right now it's 6 triangle parentheses 7 triangle 8, and if you change it like this, they should be equal to each other. Okay, so to check that, you have to do parentheses first, just like we do everything in math, because that's the whole point of a parentheses, is to emphasize that this has to happen first. So 7 triangle 8, 7 on the row, 8 on the column, that matches up with the number 7. 6 on the row, 7 on the column. 6 on the row, 7 on the column, that matches up with 7. Oh, it doesn't look good for the associative property, right? Because 6 triangle 7, 6 on the row, 7 on the column, those match up right here at 7. And then 7 triangle 8, that means we do 7 on the row, 8 on the column, find out where those two meet. Oh, actually, so far so good. Now this is just one example of the associative property. It works for one particular example. And the really tough thing with these problems is that there's a lot of different possibilities. We got to check another one. We did 6 triangle 7 triangle 8. Let's see if we switch it up, if it still obeys the associative property. The good news is, like, once you found one example that doesn't obey the commutative property, you don't have to do any more checking. You know it doesn't satisfy the commutative property. Because with these properties, it has to work for every possible example. And that's why the associative property one is almost impossible to check every option, because we'd be sitting here all day, right? There's a lot of different permutations, and it takes a while to do them. Okay, so again, the associative property, look, everything's going in the same order from left to right. I've just switched the parentheses around. These should equal each other if it's going to be the associative property. Okay, so 6 in the row, 8 on the column, that gives me 8. 7 in the row, 6 in the column, that gives me 6. And then to figure out what 7 triangle 8 is, 7 in the row, 8 on the column, that gives me 7. And then we got 6 in the row, 8 on the column, that gives me 8. I tried another example and it didn't work. So since there's one example in this table that does not obey the associative property, we say it does not have the does not satisfy the associative properties, or property, singular. Okay, so with this question, we'd say it's neither commutative nor associative.